This is the third video in the Our Finely Tuned Universe series. In this video, I'll look at some reasons why our universe is finely tuned. But it's first worth having a quick recap of what we've discussed in the previous two videos in this series. The universe is governed by four interactions which have very different relative strengths: electromagnetism, gravity, the strong interaction which gives rise to the nuclear force binding together the particles in atomic nuclei, and the weak interaction. We believe our universe is 13.8 billion years old. It began in a state of exceedingly high density, which we call the Big Bang. And it's been expanding and cooling ever since. The universe has an incredibly low average density, equivalent to only 7 atoms of hydrogen per cubic metre, and is 5% ordinary matter, 27% dark matter, and the remaining 68% is dark energy. As we've seen from the previous videos, the strength of the four forces and the fact that we have a particular amount of dark energy, dark matter and ordinary matter in the universe appears to be finely tuned to allow for our existence. So it's legitimate to ask the following questions. Why have we got four forces rather than 3, 5 or any other number? Why do these forces have their particular relative strength? Why is gravity so weak, for instance? Why is the universe made up of 5% ordinary matter, 27% dark matter and the remainder dark energy? Or even, why does space have 3 dimensions? There are 3 possible reasons why the universe is finely tuned to allow for existence. So in this video, I'll go through each one in turn. The first one is called the theory of everything. This is a deep, underlying, as yet undiscovered theory which fully explains all physical aspects of the universe. The relative strengths and the way the four forces operate are fully explained by this theory, and it should also describe why the amount of matter, dark matter and dark energy in the universe have the values they do. And would also have to include quantum theory, which describes how the world appears on a very small scale, and general relativity, which is Einstein's theory, which describes how gravity works under extreme conditions. It would have to explain what happens at the very centre of a black hole. Does a singularity of 0 volume and thus infinite density really occur? Finding a theory of everything would build on the tradition of the work over the last 200 years to discover the underlying physical laws of our universe. In the late 19th century, James Clerk Maxwell, who was one of the greatest ever scientists, unified electricity and magnetism into something we call electromagnetism. He was able to show that light was a wave of oscillating and electromagnetic fields. The speed of light was determined by 2 constants which had previously been measured. In the 19th and early 20th century, physicists determined that many forces which had been thought as separate phenomena, such as the friction which occurs when an object moves against a rough surface, air resistance and air pressure, are caused by forces between molecules, and the root cause of these intermolecular forces is the electromagnetic force. As discussed in a previous video, the chemical bonds which bind atoms together into molecules, on which the whole of the science of chemistry is based, are the result of a combination of the electromagnetic force and quantum theory, which explains how the world operates on very small scales. However, even if a theory of everything does exist, which of course it may not do, the relative strengths of the four forces could be free parameters, which would mean they could have any values at all. We just happen to be in a universe which have the right values necessary to allow the evolution of galaxies, stars, planets, and eventually support life. And even if the relative strengths of the four forces weren't free parameters, were actually explained and set by the theory of everything, the values for the density of matter, dark matter, and dark energy, which are crucial for the emergence of galaxies, stars, and life, were not set by the theory. Another possibility is that the universe has been created this way. The rules of the universe have been set up beforehand so that we have a universe which will allow galaxies, stars, planets, and life eventually to emerge on at least one planet. And when we say the rules, what we mean is the fundamental laws of nature, how the four forces work, and the fundamental constants such as the strength of gravity and the speed of light. The amount of matter, dark matter, and dark energy we have in the universe, and the way the universe works on a small scale, quantum theory. So some natural questions we can legitimately ask is, what sets these rules? Let's give it a name. Let's call it the rule setter, for instance. Then is the rule setter part of our universe? But our universe came into being at the Big Bang. Before the Big Bang, the universe didn't exist. So if the rule setter is part of our universe, it wouldn't have existed before the universe was created, and then couldn't have set the rules. So you can argue then that the answer must be no, it's not part of our universe. So the rule setter isn't in our universe. So let's call the universe the rule setter belongs to a higher universe, the higher universe. So who sets the rules for the higher universe? Well, the rule setter can't, because this rule setter entity is in the higher universe. So we need a new entity which we'll call the super rule setter. And then of course you can ask the question, which universe does the super rule setter belong to? It can't belong to the higher universe because it needs to be outside this universe to set the rules. So there must be a higher universe. And the rules for this will be set by a super rule setter who's outside this higher universe. And you could go on and on like this. And effectively you end up with something called infinite recursion. Closely related to this is the simulation hypothesis. To put this simply, this means that the entire universe we live in isn't real. Instead, everything we experience is a simulation created by a more advanced intelligence. The laws of physics which govern the universe are just rules which have been built into the game. The vast majority of cosmologists reject the simulation hypothesis, believing it to be more science fiction than science facts, but it does have a number of prominent supporters. Elon Musk probably being one of the most famous supporters. Another possibility is the multiverse. Our universe, with a capital U, is one of many different universes with a small u. In some of these other universes, the laws of physics might be very different from our universe, making conditions totally impossible for life to emerge. In the Past two videos, I've discussed some of these scenarios, but it might be worth going through a few of these again. In some universes, there might be much more matter than ours, or the force of gravity might be, for example, 1,000,000 times stronger, which would have roughly the same effect. In these universes, a period of time after the Big Bang, the expansion would slow down, stop, and the universe would start contracting, and it would eventually collapse into a singularity of infinite density, zero volume, before life had the opportunity to emerge. In other universes, the nature of the forces might be very different. For example, if the nuclear force didn't exist, then the only atomic nucleus which could exist would be hydrogen, which is a single proton. The only atom which could exist would be a hydrogen atom having a single electron orbiting this proton. In such a universe, clouds of hydrogen gas would collapse under gravity, but stars could never form from these clouds because they couldn't produce any energy by fusing hydrogen into helium. The other thing to think about is, in such a universe, if hydrogen is the only element, there's no chemistry and so no life. Such a universe might contain something like brown dwarfs. In our universe, brown dwarfs are objects which are more massive than the giant planets, but less massive than stars. They have masses between 1.3 and 8% of the Sun, which is too low to burn hydrogen into helium. But despite this, they can still generate energy two ways and glow faintly in the infrared. The first way is the same way that Jupiter does in our solar system. Jupiter actually puts out more energy than it gets from the Sun, and it does this by the energy released as it slowly collapses under gravity. The second way wouldn't be available, which is the very slow fusion of deuterium, heavy hydrogen, into helium. Some universes might have more, or indeed fewer than 3 spatial dimensions. Mathematically, it's possible to construct objects such as a tesseract, which is a 4-dimensional analogue of the cube. So, just as a surface of the cube has 6 square faces, the hypersurface of the tesseract has 8 cubical cells. It's not actually possible to construct a tesseract because we live in a world with 3 dimensions, but you can represent it like I've done here in 2 or 3 dimensions if a little imagination is applied. However, a universe with less than 3 spatial dimensions is too simple to allow any form of complex structure. And if there are more than 3 spatial dimensions, stable orbits aren't possible. A slight perturbation would cause the bodies to collide or to spiral away from each other. Life is only possible if the universe has 3 spatial dimensions. So, if the multiverse theory is true, most of these other universes have conditions in which life can never evolve. We just happen to live in a universe, our universe, with all the right conditions. But of course, if we lived in an alternative universe, where the laws of nature were such that life couldn't emerge, we wouldn't be around to observe it.